We try to answer these questions. Diagram 7 shows the graph of volume of carbon dioxide again time. So to measure the rate of reaction, we need to calculate volume of carbon dioxide gas release every interval of time. Alright, so we try to check the first question. A student add calcium carbonate crystal until excess into hydrochloric acid. The volume of carbon dioxide gas is collected in the gas syringe, and they plotted the graph. So based on this reaction, we try to write down the balanced chemical equation. So I put hydrochloric acid react with calcium carbonate. We will get calcium chloride plus carbon dioxide and water. So we try to balance chloride 2, so I put 2 in front of hydrochloric acid, balance the chloride, hydrogen 2, so hydrogen 2, so the reaction is balanced. Right, now we try to calculate average rate of reaction. So we want to find the average, alright, rate of reaction. So we need to find for overall reaction, so we need to find the maximum volume of carbon dioxide gas collected against the time taken. So from the graph, we try to find the maximum volume of gas collected, so the maximum volume is here. So we try to find the time taken, which is 150, so we put here 150. Alright, so now we go for maximum volume of carbon dioxide gas collected, so the maximum volume will be here. Alright, so the maximum volume is this. So this is 31, 32, 33, 34, 35, 36 and 37. So the maximum volume is 37 cubic centimeter. So the maximum volume collected is 37. So we try to find the answer 0.25 cm power 3 per second. Alright, so now we move on to the next question. Question rate of reaction at 75 minutes second. Alright, so here they didn't put average, so therefore we need to find the gradient. Alright, so I put here gradient of tangent. Alright, so how to find the gradient of tangent? First of all, we try to check the scale for this one. So here we have total 10 box, and the 1 centimeter equivalent to 30. So here 30 divided with 10. So each small box represents 3. Alright, so now we need to find the rate of reaction at 70 seconds, 75 seconds. So this will be our 45. Alright, 50, and this will be our 75 seconds. So I go up until I touch the gradient of tangent. So I need to find the gradient of tangent. So here I take this point, alright, circle bracket. So I need to find my x2 and y2. So my x2, y2 will be alright, so this is 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So my y2 will be 39. Alright, so my x2 will be here 90. 90 plus 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. So I use this one. So this is my y2. Right, so here I got total 9 box. So 9 times 3, that will be 27. So 90 plus 27, that will be 117. Alright, so I put here 117. Alright, so next I try to find the coordinate of this one. So here I need to find my x1 and y1, x1 and y1. My y1 so will be here. So this is 21, 22, 23, 24. So 1 will be 24. So my x1 will be, alright, so this is 30. Alright, so 30. So here I need 1 box. So 30 plus 3, that will be 33. Now I try to find the rate of reaction at 75 seconds. So that will be y2 minus with y1 divide with x2 minus with x1. So my y2 is 39 minus with 24 divide with 117 minus with 33. Right, so the answer will be 0.179 cm power 3 per second. Alright, so the set of experiment carried out to study the effects of temperature between the sodium thiosulfate reacted with sulfuric acid. When sodium sulfuric acid reacted with sodium thiosulfate, so we will get the product. So I take out the hydrogen ion, I take out the sulfate ion, I take out the sodium ion, I take out the thiosulfate ion. During chemical reaction, the hydrogen ion combined with thiosulfate ion, sodium ion combined with sulfate ion. So I will get sodium sulfate, plus when we have hydrogen ion combined with thiosulfate ion, we will get thiosulfonic acid. Rearrange to produce sulfur, sulfur dioxide and water molecule. So we will have sulfur dioxide and water molecule. Everything is balanced, so we try to check sodium balance, everything balanced. Right, so from acid we take the important ion will be hydrogen ion. So here we have 2 ion, one is sodium ion and another one thiosulfate ion. Please remember, sodium ion already achieved stable octet electron arrangement. Therefore, this ion act as observation ion. So we take this ion, so we put here thiosulfate ion. During chemical reaction, both will join and form thiosulfonic acid. It will rearrange to give us sulfur dioxide and water. So I put sulfur dioxide and water. After this, we balance the hydrogen 2. This is ionic equation for this reaction. So how to write the ionic equation? So I put hydrogen ion combined with thiosulfate ion to produce sulfur yellow color precipitate. Alright, sulfur dioxide and water. So we balance the hydrogen 2. So I put hydrogen 2. Right. So in this reaction, the factor that investigated is known as temperature. When the temperature of reacting particle is higher, the kinetic energy of the reacting particle will be increases. So the reason for the temperature will be kinetic energy of reacting particle increases. So here the temperature of experiment 2 is higher and the temperature of experiment 1 is lower. Therefore, the rate of reaction of experiment 2 will be high and the rate of reaction of experiment 1 will be lower. Right, so now we try to answer this question. Compare the rate of reaction between experiment 1 and experiment 2 by using collision theory. Right, so how to compare? So first point, the rate of reaction of experiment 2 is higher than experiment 1. Right, so next we go for the factor. The factor that affected is what? The temperature of sodium thiosulfate. Alright, the temperature of sodium thiosulfate in experiment 2 is higher. So we compare the temperature. So how to compare the temperature of sodium thiosulfate solution in experiment 2 is higher than in experiment 1. Right, so next we go for the temperature. The reason kinetic energy of reacting particle in experiment 2 is higher. So next point, the kinetic energy of reactants in experiment 2 is higher than in experiment 1. Alright, so we go for the collision theory. The frequency of collision between. So we write the particle. So please check the particle involved in this reaction is known as hydrogen ion and thiosulfate ion. So the frequency of collision between hydrogen ions and thiosulfate ions in experiment 2 increases than in experiment 1. Alright, so we go for the last point, the frequency of effective collision between hydrogen ions and thiosulfate ion in experiment 2. In experiment 2 is also increases than in experiment 1. Therefore, the rate of reaction will be higher. So that's how we answer the question. So we meet up in next slot. Take care. Bye. See you all.